Hey guys! So, arithmetic sequences. What makes a sequence arithmetic? Well, it comes from the word arithmetic. So, in an arithmetic sequence, to get the next term, we add or subtract the same number every time. That same number that we add or subtract is called the common difference, and we always use D to talk about that common difference. So, just real quick, for example, here's an arithmetic sequence: 7, 11, 15, 19, so on and so forth. So if we notice, each time from 7 to 11, we added 4. From 11 to 15, we added 4. And from 15 to 19, we added 4. So that means that 4 is my common difference, okay? Now, when we're trying to figure out a formula for these guys, and I know I have a formula down here, and we'll get to that in a second, but what I want to do right now is just talk about how we can just kind of organically figure out where these, what these formulas would be. So first of all, I know I'm going to add 4 every time. So when I add 4 repeatedly, or when I have any sort of repeated addition, remember that means multiplication. So what we want to do is we want to take that common difference, which is 4, and we're going to multiply that by which term we're on. So now to figure out how we have to change this up a little bit to fit our specific sequence is to maybe plug 1 in for the first term and figure out what we have to do. So if I plug in 1, I get 4. What do I have to do with 4 to get to 7? I'll add 3. Let's make sure that works for the other terms. So for the second term, 4 times 2 is 8, plus 3 is 11. Third term. 4 times 3 is 12, plus 3 is 15. Fourth term. 4 times 4 is 16, plus 3 is 19. So there's a formula for it right there. Now, arithmetic doesn't mean that necessarily you're going to add something every time. Maybe you're going to subtract the same value every time. So to get from 2 to negative 3, we had to subtract 5. To get from negative 3 to negative 8, we had to subtract 5. And to get from negative 8 to negative 13, we had to subtract 5. So that means that my common difference is negative 5. Now, since I am adding that negative 5 over and over and over and over and over, repeated addition means we are going to be multiplying. So I'm going to take my common difference, that negative 5, times my term. And now I'm going to go ahead and plug in each term and figure out what do I have to do to it to get it to match what I have in my sequence. So when I plug in 1, 5 times negative 1 is negative 5. And let's see, we need to add 7 to that to get that to equal 2. All right, here's the second term. So negative 5 times 2 is negative 10. Negative 10 plus 7 is negative 3. Perfect. Here's the third term. Negative 5 times 3 is negative 15, plus 7 is negative 8. Beautiful. And then here's my fourth term. So negative 5 times 4 is negative 20, plus 7 is negative 13. So yay, I found my formula. Now, of course, there has to be a way to just kind of plug in the stuff I know and go from there and have an explicit formula for it, right? Yeah, absolutely. So here's how we find the nth term of an arithmetic sequence. It's also how we find the explicit formula. These two terms are these two words basically mean the same thing. I'm asking for what's the formula for this sequence when it's an arithmetic sequence. So you're going to take your first term plus the common difference times whichever term you're on minus 1. All right, so I know we didn't quite think about it this way up here, but you can also think about it right here. If you didn't have this minus 1, if you took the common difference times the term number, we wouldn't end up with our first term. See what I'm saying? Okay, so here we go. Let's solve a few. Find the nth term for the arithmetic sequence whose common difference is 3 and whose first term is 2. So just a second ago, we learned about what these formulas were. We knew that it was going to be a sub n equals a sub 1 plus d times n minus 1. Now, a sub n is, we're just going to keep it right there. That's saying this sequence term, whatever. A sub 1 is my first term. They told me that my first term was 2 plus. And then they told us that our common difference was 3, so 3 will go in for d. And then we can keep that as n minus 1. Now, if you want to just keep it just like that, that's totally fine. However, when I have to plug things in a lot, that can get a little bit annoying. So it might also be nice to clean it up a little bit. If we were to distribute that 3 out, we'd end up with 3n minus 3. Combine it with that plus 2 at the end, so I end up with 3n minus 1. Now this next one is going to get a little bit more complicated because they're not just going to tell us what we want. It's going to tell us that the first term of an arithmetic sequence is 20, and the 13th term is 65. Write the explicit formula. So let's think about this. My 65th term is going to be equal to my 4th term plus that common difference happening how many times from the 4th to the 13th term? Let's see, that's going to happen 9 times. So I'm going to multiply that by 9, because remember, that common difference is going to happen 9 times from the 4th term to the 13th term, because 13 minus 4 is 9. Cool. So now we can go through and figure out what is our common difference. So my 65th term was 65 equals, and then my 4th term was 20 plus 9d. Then we'll solve, subtract 20. So 45 equals 9d. So then that means that d is equal to 5, or my common difference was 5. So now we can go and, since we're trying to figure out the explicit formula, remember we need the first term along with my common difference. So here's one way you can go about it. My 4th term was 20, right? So that means my 3rd term had to be 15. That means my 2nd term had to be 10. That means my 1st term had to be 5. So let's write this formula. A sub n equals, first term is 5 plus my common difference is 5 times n minus 1. And I'm just going to keep it just like that. So this extra step that I did right here isn't really necessary unless you really have to work with that equation a lot. Then I would simplify it. Okay, so now we have the 3rd term of an arithmetic sequence is 19, and the 15th term is negative 1.7. Write the explicit formula. So you might have been able to reason through the last one by just using patterns, and it might have been kind of easy to find since they were nice round numbers. With negative 1.7 and 19, it's going to be more difficult to do. So let's reason our way through this guy. So first of all, we know that the 15th term is equal to the 3rd term plus the common difference happening 12 times. So I need to multiply that by 12. So then I'll plug in what I know. I have negative 1.7 for for a sub 15. And we have 19 for a sub 3 plus 12d. All right, so the next thing we have to do is subtract 19 on both sides. So that will give me negative 20.7 equals 12d. And when we divide both sides by 12, we're going to end up with negative 1.725. So here's what we can do from there. If we have 19 as the third term, here's what I'm going to do to find my first term. I'm going to take 19 and I'm going to add 1.725 to it. And that will give me my second term. So my second term is at 20.725 right there. So then to find my first term, I need to add this again, since remember, I'm going backwards. So instead of subtracting, I need to add. So I'm going to add 1.725 to that answer. And then my first term is 22.45. So we just found out that a sub 1 equals 22.45. So if we write this formula, a sub n equals, we need our first term, 22.45, plus our common difference. Well, this time, since it's negative, we can put that as minus 1.725 times n minus 1. Good deal. All right. The fifth term of an arithmetic sequence is 16, and the 14th term is 8.5. Write the explicit formula. All right, here we go. So the 14th term is equal to the fifth term plus the common difference happening 9 times. So I need d times 9 there. Then we'll plug in what we know. The 14th term was 38.5 equals, the fifth term was 16 plus 9d. Subtract 16, so we get 22.5 equals 9d. Divide by 9 on both sides, so d equals 2.5. So it looks like for every term, we're adding 2.5. So I have the fifth term. I want to go back and find the first term. So instead of adding 2.5 every time to go backwards, I'm going to subtract 2.5. So I'm going to take 16 minus 2.5. There's my fourth term, minus 2.5. There's my third term, minus 2.5. There's my second term, minus 2.5. There's my first term. So it looks like my first term is 6. All right, so a sub n equals my first term, which is 6, plus my common difference, which is 2.5, times n minus 1. All right, so now we learned a little bit about arithmetic sequences. What happens when we turn them into a series and start to take some sums? So if we want to have the sum of some sort of finite, I also need to add in here arithmetic. Should be an arithmetic sequence. So the sum of the first n terms is going to be the number of terms divided by 2 times the first term plus the nth term. All right? So that's one of the things that if you are taking IBSL2 with me next year, that you will be have access to this formula on that formula notebook. You will not need to memorize it. If I were to be teaching this in not pandemic times, I would give you that formula. I don't expect you to have it memorized. So I might write it on a little sticky note or somewhere close to me so I can keep it out in front of me and reference it often. Okay. There we go. All right. Now I want to find the sum. So I want to find the sum of 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19. Okay, so first of all, I am taking the sum of the first. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. So S sub 10. So since I have 10 terms, that's what's going to go on top of my 2 times the first term, which was 1, plus the last term, which is 19. Okay, now, absolutely you can pop these in your calculator. I just want to save time and also show you why this is worthwhile to know. So 10 divided by 2 is 5, and 1 plus 19 is 20, and 5 times 20 is 100. See, that wasn't that difficult to do that mentally. However, grouping together all these different numbers, trying to make nice things to add together, if you just wanted to go up and straight up find the sum of all those numbers, you could, but it's just not time efficient. And if you have more than 10 numbers, 10 is digestible at least. What if you had to do 600 numbers? That would be a pain in the butt. But if you knew you had 600 numbers, the first term and the last term, by golly, that's a whole heck of a lot easier. So it is worthwhile to know these things. All right, let's look at the next one. 1 plus 4 plus 10 plus 13 plus 16 plus 19. Let's see, that's 1, 2, 3, 4, 5, 6 terms. So I want the sum of the 6 terms. So since I have 6 terms, that goes over 2 times. My first term is 1 plus my last term is 19. Oh, again. Hey, fun. Come on. Okay. Now we'll simplify. 6 divided by 2 is 3. 1 plus 19 is 20. And then 3 times 20 is 60. So see, it's really not too terrible. Okay. Now we want to find the fourth partial sum. So remember, a partial sum is basically saying I want the sum of the first 10 terms. So we have a couple of different options for where to go from here. So let's go the route that we have learned today. So we know we have 8, 20, 32, 44. We know we're adding 12 every time, so that's an arithmetic sequence. So I know that S sub 10 equals, I'm going to have 10 terms since I need the 10th partial sum over 2 times. And then my first term is 8 plus, I don't know the 8th term. How can we find that? There she is. Right here. I can find my 10th term because I have my first term, I have my common difference. Now I can go through and solve for what is my 10th term. So I'm going to use this piece of information to find an explicit formula for this guy. Oops, too far. There we go. Okay. So a sub n equals, we need our first term, which is 8, plus our common difference, which was 12, times n minus 1 to find my 10th term. So like I said, I want to find my 10th term. So a sub 10 equals 8 plus 12 times 10 minus 1, or 8 plus 12 times 9. That's going to leave me with 116. Good deal. So now I can go through and solve and say that 10 divided by 2 is 5 times, and then 8 plus 116 is 125. And then 5 times 125 gives me 620. Now, let's say that you had a calculator with you. Wouldn't that be nice? Maybe you do right now. Let's think of a different way to solve this problem. So these are two different ways to solve the same problem. Doesn't matter which one feels good to you, okay? Now, if you remember when we learned about series, we learned about summation notation. So we might go from n equals 1 to, I want the 10th partial sum, to 10 will be my upper limit. And then inside of here is my explicit formula for that sequence. So that's my 8 plus 12 times n minus 1. And then we can pop it into our calculator. So we will real quickly click on math, go up until you get to summation at 0, press enter, and then we'll put in everything. X equals 1. On top we need the 10. 8 plus 12, parentheses, x minus 1, close parentheses. And we end up with the same answer. So however you want to approach these is fine with me. I want you to have a good handle on approaching both of these, because at least from an IB perspective, I can tell you for sure that you will have to do this by hand. You will not be allowed to have a calculator. Though some of you guys might feel better using your calculator and doing it this way, and you think it saves some time. Cool, doesn't matter to me, whatever works for you. Now we want to find the 150th partial sum. Ugh. Okay, so first of all, let's figure out what is our common difference here. So from 5 to 16, we added 11. Does that work for the rest of them? 16 plus 11 is 27, plus 11 is 38, plus 11 is 49, for sure. So that's our common difference. So I'm going to go ahead and figure out my explicit formula for this first to save me a little bit of time. My first term is 5 plus my common difference was 11, and that's always times n minus 1 from that formula that we got at the beginning of class. So if we are going to rock this the non-calculator way, which I think we should. I'm so sorry. There we go. Okay, so non-calculator way. We want the sum of the first 150 terms. So I'm going to have to take 150 divided by 2 times, and then my first term was 5 plus. And now I need to figure out what was my 150th term. So I'll take 5 plus 11 times, and then 150 minus 1 is 149. Oh my goodness, I so don't. That's 1,644. So 1,644. So I would agree with you. I don't want to do that by hand. I would use my calculator. When we throw that all into our calculator, we should end up with 123,675. All right. So next time we're together, we will talk about geometric sequences. So I miss you guys so much. See you later.